Hello, welcome children to channel Sube. Today I am going to discuss question number 45 from MCQ part of 2019 Physics new syllabus. Three cells with electromotive force E1, E2 and E3 and internal resistances R1, R2 and R3 respectively are connected as shown in the figure. Which of the following expressions gives the potential at point P of the circuit? So point P is given here, so we have to find the potential at that point. So now first of all, let's alter a little bit in this given diagram to get it to the appearance that is familiar to normal circuits that we solve in the classroom. So instead of this ring, so there is a, you see the ring, there is a ring. So instead of this ring, let's draw a line and connect these batteries to that. The negative side is connected to this ring. You can see all the batteries are connected, their negative side to the ring. So instead of that ring, we draw a line like this. Then we connect the negative terminal of all the batteries to that line. So the same circuit, we don't change the circuit, but the diagram a little bit convert into the form that is familiar to us. So this earth now is connected to the ring, so we therefore connect it to this line. So the positive sides now we can draw like that, and the internal resistance R1 and R2 and R3 they have given, and for that they have representing these resistors, so we can draw that also like this. So this one R1, R2 and this one R3, the same diagram. So all these resistors are connected at P together. So instead of that point, we draw a line. To this line these resistors are connected. Either it is a point or a line, doesn't matter, because all these are conductors, copper lines. So from P is the point, P is the output point. From P we take the current out of these batteries. Since there are batteries, we can get current. So to find a potential, we have to use this. So the current we can take out like this from this line, because they want us to find out the potential at point B. So to find out the potential, we fix a wire like this to get current. Let us talk about the current first of all before we talk about the potential. So since there are batteries, we have to take a current. Then this output current must go back to the negative side of the battery, So therefore we have to connect the other wire to this ground. This ground means it is not the ground that where we are standing on, not this ground. We use the word ground, but it is not the ground that where we are standing on, not that ground, not the earth. Sometimes we say earth this to this symbol, but it is not that earth. It is the ground of this battery. We call this negative side ground or earth. Sometimes we call earth, because the current flows and finally falls to this ground. This one is the ground. Therefore, if we released a stone here, finally it stops at this ground, what we call ground. Not that ground, the same thing happens to the current. The current stops at negative side after falling through these resistors whatever we have connected to complete the circuit. So say there is a resistor like this without batteries, so I don't take these batteries to explain because it is complicated then. So imagine the current flows like this, and through this resistor it flows and finally finish at this negative side. So that means this one is the ground for current, that is why we say that symbol is ground. So therefore we have to connect a wire to get current out of this circuit, and sometimes we can light up a bulb even to fix this bulb to these two wires, and we can light up the bulb because there are batteries. So the same way, to find out the potential at this point, we have to connect a voltmeter like this, voltmeter. So it has a needle like this, a scale. So the negative wire of this voltmeter we must connect to this place where we call ground. The positive wire of this voltmeter we must connect to the place where the positive terminals of the batteries are connected together, that is P point, the point P. So this way we can get a very small current. If this one is a voltmeter, very small current which is negligible to deflect this needle. The needle must be deflected like this. The needle must move. Therefore we need a very little tiny current, so that is negligible. Therefore we have to connect somehow this circuit like this. Therefore we have to now connect a wire like this and consider focus our mind to this current. So this current we can imagine, we can assume it is 0, because we know voltmeters don't absorb current. That is a standard condition. If it is a voltmeter, we say that the internal resistance is infinite, therefore the current absorbs is 0. So the same thing we have to do here. So we have to draw this diagram like this, and the output wire we have to draw like this. This one is the output wire, this place is the junction P that they have given. So we can now mark the current, say, so in these equations the current is not there, but we have to use the equations, the basic equations. They have current I. So say this one is I1, this positive, these are positive terminals, so the current must come up from here. Then this one say I2, this one say I3. So the current here along this line from P point, from the point P, the current must be 0. Current must be 0, because then only we can measure this voltage as V. Otherwise it is a lower value. You know, the electromotive force is what when the current is 0, the voltage difference between the cell, terminals of the cell. So we can measure this voltage. So that is what they want us to find, give the potential. So potential is the voltage relative to this terminal, this earth. So that means the voltage between these two lines. So we have to find out it. So we have to convert this complicated diagram to a simple form like this without changing the circuit. We haven't changed the circuit, the structure is the same, but we have extended and stretched the wire so that it looks like this without this circular shape. This rectangle shape, we have converted it to a rectangle shape because we are familiar with these types of circuits. We are not familiar with these types of circles. Therefore then it will be easier for you to understand. So let us now try to find out this V. So now this is the circuit that we were discussing about. So we connect this wire to the voltmeter and then connect this wire to the ground. Then if I is very tiny, negligible, we can say I equals 0, then we can see, we can get a reading from this voltmeter. So instead of this voltmeter, I replace a resistor, because the internal resistor of a voltmeter is normally 100 kilo ohm. So here instead of that voltmeter, I replace a 100 kilo ohm resistor. So the current we can assume 0. So let us apply Kirchhoff's first law to this circuit now, to this junction. This is our this is the junction. This is our junction. So what is the Kirchhoff's first law? Algebraic sum of the currents at a junction is 0. So therefore we can write algebraic sum means the current coming into this junction, the total current is equal to the total current leaving this junction. So we can write I1 plus I2 plus I3. Those are the currents flowing into this junction equals the current leaving the junction, that is 0. That is 0 according to this discussion. So let us now simplify this. Let us keep somewhere else. We don't want that now. So this one is the equation from Kirchhoff's first law. Now you know that if there is a battery like this, the other side, let's write. If there is a battery like this and we are taking a current like this, say I. If the electromotive force is E and the internal resistor is simple R, tell me the equation for voltage between these two terminals of the battery. What is the equation for V? V equals, using these symbols you must be able to say that V equals E minus I R. This equation you must know. So we have to use it here now. So from this equation we isolate I equals, we take IR term to this side, then it becomes positive, then we take this V to this right side, then E minus V divided by R. So we have to substitute that I to this equation. So now we write, instead of I1, E1, because there are 3 cells, the EMF is called E1, E2 and E3. So for this line we write E1 minus V. V is same, not V1, 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 V2 and V3, just V, because only one V is there. All the V's are equal. So E1 minus V divided by R1. R1 here, the resistor is R1. So like that we write, then I2 equals E2 minus V divided by R2. Then I3, E3, because that current is coming from this E3, this I3 current, therefore it is going through this internal resistor R3, therefore E3 minus V, V is this V, but all the V's are equal, so divide by R3 must be equal to 0. Now we separate this E1 divide by R1 minus this 2 V divide by R1, V divide by R1, then plus E2 divide by R2 and minus V divide by R2. We simplify this term, then plus E3 divide by R3 minus V divide by R3 equals 0. Now we take all the V terms, this one and this one, to this side, because we have to isolate V now. Therefore we take V first, this one, V divide by R1, then it becomes positive, we don't have to write it. This one also becomes positive, V divide by R2, this one and this one, positive V divide by R3 equals, then here these terms stay, E1 divided by R1, E2 divided by R2 plus E3 divided by R3, this one. Now we take V is common out of the brackets, then 1 over R1 divided by 1 over R2 plus 1 over R3. Then here we don't have to do anything here because we can't take anything, there's no common part, so we write like this. So the same thing, E1 divided by R1, E2 divided by R2 plus E3 divided by R3, like that. Now we have to simplify. We take R1, R2, R3 here to the denominator, then E1 times, we write R2 times R3. That means we have to write without this one, the other two we have to write, excluding this one we have to write R2 and R3. So that way, plus E2 times, excluding this one, R1 times R3, R1 times R3, then plus E3 times, excluding this one, then R1 times R2, like that we write. Then to the right side, what we do, the same thing, we write R1 times R2 times R3, then 1 times, excluding this one, the other two, so we don't have to write 1, then R2 times R3, the same way, plus 1 times, this one is 1, excluding this one, the other two, that means R1 R3, then plus 1 times, because this one is 1 times, excluding this one, the other two, R1 times R2. So now we have taken this one, so we can cancel this R1, R2, R3 because left side and both side this term appeared. So now let's cancel R1, R2, R3 from this side. Then we can take only what is remaining, this one and this V, and this part. This part goes to the other side. When we take this part from here to this side, it goes to the denominator. So we receive such an expression for V. So I think this one is the answer. So let us check it. with the answer they have given. So this the answer, the fourth one goes with that one. Let us check. Let's keep it here. So E1 R2 R3, E1 R2 R3, E2 R1 R3, E2 R1 R3, E3 R1 R2, E3 R1 R2, then R1 R2, R1 R2, R2 R3, R2 R3, R1 R3, R1 R3. Okay, correct. So children, this one is the answer. The fourth one is the answer. I think children, you must be able to understand this. It is not a difficult one, but you should know these basic physics before you write the answers, the equations, before you go to Kirchhoff's law. If you don't know this basic physics, then it may be a difficult question for you. So anyway, I think you can understand now. I think you are happy. Then I think you will subscribe my channel. So let us again meet tomorrow at 6 o'clock. So long, goodbye.